And we are live. Welcome, everyone. My name is Daniel, and I will be the host of this Tech Excellence Meetup. So I would say, let's get started. Our vision is to raise the bar of technical excellence across the world. Here are our organizers. First and foremost, Valentina Jemovic, and she's the founder and organizer of Tech Excellence. Next to her, we have Alina Liburkina, who is also a co-organizer of these sessions. Next to her, we have Oliver Ziller, another co-organizer. And last but not least, me, Daniel Moka. Here are our speakers from the past. We have already really great and exciting sessions. All of them are recorded on YouTube. So if you are interested in them, go and check them out. And as you see, we already have a few great sessions already planned for the future. So stay tuned with us. And of course, we are available on a lot of platforms. First of all, our main website, techexcellence.io. And you can follow us on Meetup, YouTube, LinkedIn, X, GitHub, and we have a Discord community. Feel free to join us if you have any questions about tech excellence. Huge thanks to our sponsor, Optivem, and to our partner, QE Unit. Yeah, so we are Tech Excellence. Learn how to deliver quality software faster. And let me introduce the speaker of today, and who is Jonas Felix. He's a founder and trainer at letsboot.ch, based in Basel, Switzerland. And he's over more than 100 training days. He got the chance to teach more than 500 software engineers in orchestrating their software projects and automating their CI/CD pipelines. Pretty impressive. And before his trainer career, he built and successfully sold 2 companies. So another impressive background information. And the topic of the today is crafting your CI/CD pipeline and orchestration. So welcome, Jonas. We are very happy to have you. And before I hand over the microphone, I would like to remind the audience that if you have any questions during the session, feel free to ask your question in the chat section of YouTube. And at the end of it, we will dedicate half an hour to answer any questions you will have. Namely, Jonas will answer these. So, Jonas, I would like to say good luck for this session. We are super excited. So the microphone is yours. Good luck.
So thank you very much, Valentina and Daniel, for inviting me and for this great introduction. I want to talk to you, everybody, about crafting CI/CD pipelines and a really important part, the orchestration. And how do we want to do this? We want to do this with a certain ownership. So I already got introduced, so I actually don't have to talk that much about this. As mentioned, I'm mostly doing training and architectural workshops at Let's Boot. I really love teaching, and I really love open source community, everything surrounding tech. And I live in Basel with my family, 2 kids, and that's kind of like my highest priority. By the way, Alina and Jimmy will be teaching next week at Let's Boot in Zurich. So if anybody wants to check that out, everything else you will find on our website. So let's dive in. I want to talk about the question, which is our code changes, how to get them to run somewhere with multiple people working on the same code base and target systems which we want to deliver to automatically. The parts of this process I want to talk about is continuous integration, continuous delivery and deployment, and the very important part, the orchestration part. So let's first look at what I mean if I mention those 3 parts, because not everybody talks about the same thing if they mention those 3 parts. So let's first look at continuous integration. And if I talk about continuous integration, this talk, I actually mean the continuous integration of work. Why do I say this? Often when we talk about continuous integration, we talk about the CI pipeline. which is really important. And of course, we will talk about the CI pipeline today. But actually, the CI, this continuous integration, is happening here. The continuous integration is us contributing changes to a central point, usually a Git repo, and then others or ourselves basing our work on this contribution. So this is integrating, contributing, basing on, and merging what we do. And now the continuous part is about how frequently and we do this, and the continuous integration pipeline is how much confidence we have in this. So instead of doing something like this, someone is working here, someone is working here, and then we basically bring our change together after whatever few weeks, and then we struggle here, merging and integrating our changes. What we actually want to do is we want to chunk our work in smaller parts so that we can actually build our changes based on the other person's or the other team members' changes in a higher frequency. So what should the CI pipeline do? The CI pipeline should give us the confidence that we can integrate more often. This is really important. The CI pipeline I want to talk about is the thing that enables us as software engineers to know that we can base our work on somebody else's contribution. And this is what should be put into the CI pipeline, because it should enable us to do this continuous integration. And this can be, of course, very different from each project. And this can also evolve over time. Now we have the continuous delivery or deployment part. When I talk about delivery or deployment, continuous delivery or deployment, I kind of use it synonymously, because if you go into the really nitty-gritty separation of delivery or deployment, if you go to Wikipedia, it actually both mean that you enable fully automated deployment at any time. We can discuss about the at any time part. That may be different to who you ask, but the enable fully automated deployment. Now the delivery deployment difference lies in the when and how it's triggered. But it actually doesn't really differentiate how you automate it. It's more like when you start the automation. That's why I more or less use it synonymously. And of course, there are projects where you can argue about it should be different, called like this or this. So we'll just use it as the same thing. So continuous delivery and deployment allows us to take whatever we have in a version that we want to deploy somewhere and bring it to a target system. This doesn't necessarily have to be production. This can also be a review environment for branch. This can be a staging environment. It's all the steps we need to automatically bring our deployment to a target system. That's, by the way, also the reason why we have this overlap here. Because CD and CI are not that easy to really separate completely. Of course, you can separate it in jobs or actions or whatever tooling you use, but they feed into each other. CI can be dependent on CD, CDB. CD is usually dependent on CI. And now we have the orchestration, something that at the moment, depending on the point your organization is at, can be quite neglected, or it can be quite far away from the software engineering team. It can come from the software engineering team. really depends at what stage you are, and of course also what kind of system you use. I naively assume here that we mostly talk about something like Kubernetes. We most usually talk about something like containers, but obviously you could apply similar things to other ways of orchestrating and other ways of defining how things should be treated during runtime. And that's also the keyword I'm just talking about. And the keyword is orchestration enables continuous management during runtime. Obviously, if you have a single process running on a single machine, you could create a system script and just make sure it's restarted whenever it crashes. But that's usually not the reality we live in today. We have things we have to solve during runtime, things considering scaling. What happens if there is need for more resources to serve more requests? What I just mentioned, like restarting because of something the system realizes about a part of it. Like if one of the processes doesn't do anymore what it should do, there should be some kind of life cycle, some kind of restarting. We have maybe memory, CPU behavior that we want to think about, what we want to do in which cases. We have different kinds of update strategies. That could be a replacing strategy, a rolling update strategy. It can be different for different parts. And the whole topic of health. So there are a lot of things. Of course, we have configurations. We have sometimes networking. And all of this is kind of running under this topic, orchestration, as far as I want to look at it in this talk. And now if we go a step back and we forget about the CI, the CD, and the orchestration, and we just look at our software project. What we usually have is we have a lot of different factors which influence the way we choose patterns, architectures, our next steps, our dependencies we want to build on, patterns we want to choose. There are many really important decisions to make because of different factors influencing our project. And obviously there is no single truth for every project, as much as we wish to have it like this. For example, I really love mono repositories, but I understand that there are so many projects where a mono repository approach with this kind of team and system and maybe also team structures and dependencies, a multi-repository strategy makes more sense. So we have things like the knowledge of the team influencing how we build software. We have timeline and priorities. As much as we don't want to talk about them, they influence our project. We have the phase of the project. Maybe we want to work differently on a project if it's like a first version, minimal viable version we want to deploy, or if we're like 10 years into the life cycle into a project and we're kind of like integrating new features, or maybe we even like have a parallel refactoring of it. There are so many different scenarios. Obviously, we always have an ecosystem. We want to look at what we want to choose to do, and of course, project requirements for something we actually want to build something. So what I often see is we have these software projects, and all the teams have their different priorities and strengths. But what I rarely see, I mean, there are projects, but what I rarely see is that the CI/CD orchestration is part of this. I often see this kind of like as a separate thing. It could be a silo thing that it's provided as a service, which isn't in general bad. I will show you at the end. but you have to think about it, how you do it. Or it could be an afterthought. It could be a single person in the team just struggling to get the things running. So the CI/CD orchestration part is often kept a bit on the sideline, and it's more like a reactive part. Like if here something doesn't work the way we want, we go as an afterthought. We go to the CI/CD orchestration part. But what I would like to see more, which isn't easy, I know, what I would like to see more is that you actually put this whole thing into the center of your project. So you say, we're multiple software engineers or participants in a team working on our code. And of course, your code is king. The code is what we want to deliver. But as part of the project, we want to see CI as something enabling us as a team to perform with a higher velocity and with higher confidence. We want to see CD as a way of feeding into CI, because often we have to deploy something to even do testing on it. And we want to have orchestration to have a single source of truth how things should be managed or behave on runtime according to the orchestration solution. And obviously, the smoother and the faster we can deploy to a target system, the faster we get feedback from our end user, the less time we waste with fixing for releases, fixing after the first release, and so on. The less time we have to spend with fixing our own things we wrote like 4 or 5 weeks ago, which we don't exactly remember anymore. So I try to write down a few sentences about these 3 topics, and also try to give you examples of what I think can be a bit more painful and what I think can be a bit more helpful in the whole process. So if we talk about continuous integration, and we talk about continuous integration pipelines, we should remember that this is to enable us to continuously integrate our code changes. And the pipeline has the main focus of telling us as early as possible if something is broken, and allows us to give the highest confidence to merge the things we want to merge. So the 3 things I wanted to mention is focus on what you can run always. It's much better to have a smaller set of things that you can run always. And with always, I mean, best case, before you even commit on your local machine, at least on your feature branch, and not only on the main branch. So this is the thing that really gives you the gain in velocity, is the things you can run always, and you don't have to think about, oh no, we can only run this once a night or every merge. And this means you want to fail now to fix now. And important, the CI is not something you build for management. So you don't build this for management. Of course, quality gates or whatever can be something that feeds into the information for management to take a decision. But CI is not really the main user of CI is not the management or the customer. The main user of CI is us, the developers. It should help us to be confident and quick in building our work on the others' changes and our work on previous changes with confidence. That means we should love the CI. If we don't love the CI, something's wrong with the CI. That means we should evolve the CI pipeline in a pace and in a way that feeds in our development lives, in our development like cycle. You know, this kind of like you write something You write something, you want to immediately test it, and then you want to commit it. And then you have maybe some more kind of like feedback. This cycle has to be as short as possible. And this cycle is what really is important about CI. Now, I brought you a little example, which I often see. Maybe a few of you know this. Disclaimer. The left side is not wrong. It's just something else. So maybe you know this pattern. You're a happy software engineer. You're working on your feature branch. And you have your unit tests, whatever tests or quality scans or things you run on your code, linting, security scanning, whatever you do on your feature branch. And you have a very quick feedback loop. That's the important thing, the feedback loop on your feature branch. Every time you push your commits, hopefully more often than more rarely, you will immediately know if it works or if it doesn't work. That's great. Now, at some point, if you use this pattern, somebody merges your feature branch into the main branch. And now, because of resource constraint or whatever other decisions, there is this end-to-end testing. And the end-to-end testing is maybe even written by somebody else, which is amazing. This person writes only end-to-end tests and takes workload from your shoulders, and now the end-to-end test runs on the main branch, maybe even after merging to the main branch. What does that mean? That means you, who just wrote something and you thought, wow, this works, you're gone. Maybe 2 weeks later, you're not yourself anymore. Or maybe somebody else has to fix it. And now there is a feedback that something is broken on the main branch because you merged it's merged. This information has to be checked by multiple people because we don't know who broke it. Maybe because of the branch, maybe depending on who worked on it, we know who it is, but still it will be probably you in 1 or 2 weeks. For me, this is more like something about like last border of defense. I just forgot the English word for it. Like last wall of defense before we go on production. But it's not really CI. CI should be here in our very quick feedback loop. So the best thing to do actually is to say, or maybe not the best, but the more interesting thing is like to say, but why do we just run it up there? And why is it separate? Why don't we put it down here? Why don't we have our feature branch run the end-to-end test, whatever it is, Playwright, Cypress, you name it, and make it an integral part of our daily and hourly, every minute feedback loop of working. At least run it on every commit pushed to the feature branch, and even better, enable your engineers to run it locally. So we're not like having to wait until something is merged to then have to find out what to fix. So we serve this person. The most important person is in our team, the software engineer. Now, if we go to CD, for me, CD is part of CI. Not all of it. There are some CD parts which are maybe not that important in CI, but most of it, really most of it is part of CI. Why is it part of CI? Because somebody has to write the CD. Means usually CD is code. So it's kind of software. It's maybe not Go code compiled to a binary, but it's code. It's maybe looks more like configuration, but at the end it's code. So we should treat it as code, and we should treat it as code means we should treat it as part of the CI. That's the first thing. So we should test the CD as part of our CI, and vice versa. It's also CI often depends on CD to test something. So I mean the CI pipeline. So the CI pipeline often depends on CD. For example, if you do this Cypress end-to-end test, you want to deploy your application somewhere. So you want a CD somewhere to have as part of the CI pipeline your Cypress test testing this. And all of this should be versioned, and all of this should be tested. A really important part there, which we have in most other areas of software engineering, but we often kind of like not focus on in CD, is rapid iteration. Like, if you want to work on something, you have to be able to just press run, run, run again, change something, and run it again. This makes you quicker in iterating over a solution. So if you have a solution where actually testing what you're writing as code to run your continuous delivery deployment, if you can only at the end really test it if you go in production, and you can only kind of like partially guesswork test the things you do in CD, you will probably struggle. And also an important part is you should have kind of a single source of CD. So maybe sometimes you build slightly different ways of CD, but it should be a single source that you can all agree on what you actually tested, what you versioned, what you want to use to deploy which version. So I brought you a bit of a different example for this one, which I see often out there. And again, I don't say this is completely wrong. I don't say this is wrong. I just want to give you my view on it. So let's look at the upper one. This is you working on your project happily. And within your CI, continuous integration pipeline, you maybe do a simple Helm install of your application to a Kubernetes cluster, or maybe even you just do a Docker run, or you just do a node index.js or whatever to get your dev environment or CI feature branch test environment, whatever you call it, get it running with your own kind of like little efficient, maybe very smart, direct way of getting it to run. And now you have the production system or staging system, and then production, whatever you do. And there you have like a completely different parallel world where they drive GitOps and they use Argo CD, and then they deploy by somebody clicking sync who manages this whole thing to get it running. The difficult part about this is that you're actually not testing this. You're not treating this as part of your software project. You're not treating this necessarily as part of your planning of releases, and it's getting quite hard making sure that whatever you have here matches whatever you have here, especially if you have like shorter releases, like fixes, and then bigger releases where you already have to prepare the production CD. The reason why this is often done is because those two people don't know each other, don't talk to each other that much, or don't know the same tooling as the other does. Or somebody decided that Argo CD is so hard that software engineer can just not know how to do it, or that they say GitOps is so complicated that we can't use GitOps to in our daily business. But I say, I'm pretty sure you can do this. Of course, this person here is amazing in their job, and this person too, and they don't have to have the same knowledge, but they can enable each other to share a system where they agree and they can run the things with the same with the same base, with the same single source of truth. So you can say you have your project, you have your continuous integration pipeline, and then you feed into GitOps. There are very nice solutions to feed from your CI pipeline into GitOps. And then you can use Argo CD, and then you can go to your dev review integration test environment here, and you can use the very same to go to production. And I tell you, spending the time to ensure that you can actually quickly iterate through this process, that you can treat the whole process as code, you can version it, you can review it, you can run CI pipelines on it. The initial time you spend on that, maybe the meetings to get certain permissions, maybe get an additional development instance of Argo CD or whatever you need, this time is absolutely worth it, because you will save so much on each iteration in the future. And now we have the last part, which is orchestration. So orchestration and continuous delivery deployment kind of feed into each other, but they still are somewhat different. Because continuous delivery and deployment usually ends when the system is running. We could argue about that, but I think for most projects and most systems, the continuous delivery deployment ends when the system is delivered. And maybe you do another verification. This verification maybe takes a few minutes, could take even like half an hour later or whatever. But at some point, delivery deployment ends. Orchestration usually doesn't end. Orchestration runs alongside your application. So again, we have this very interesting thing that orchestration is code. So we should treat it as code. We should test it, we should version it, we should use all the amazing patterns that we already know from engineering software. We should think about what we depend on, we should think about how we review it, and so on. So you should test and version your orchestration. And now this is an important part. You should define and own its customizability. So modern orchestration system like Kubernetes allow us to move a lot of complexity about concurrency, about scaling, about life cycle of our application, about health, about resource management. There's so many things we can push towards orchestration. Sometimes we have to, maybe we don't want to, but sometimes we have to, but we can and we do push it into orchestration. But now this also means that we kind of have to know how it does it, how it does the concurrency management, how it manages the resources, how it manages scaling, how it manages life cycle, when does it restart our application, when does it decide that our application should get traffic, and so on. There's so many things that is now put into orchestration. And as we have it with our software, where we probably have some kind of configuration file or some way to configure our software, we should also think about like, okay, we have this kind of orchestration that fits our software, our project. And in addition to the configuration for our specific project and software, we have the configuration for the orchestration, which keeps it running. So we should actually own the bandwidth and the option we want to provide to the people who actually put it on a specific system with specific parameters. So to give you another example in this area is it's obviously a bit like humor. I try to make it a bit funny. I'm not sure if I managed to do that, but let's look at those two sides again. It's not like this is completely wrong. It's not like this is completely wrong. It's just, it has certain trade-offs. So look at the left side. You're writing your code, and I just took the very easiest example we can all kind of imagine. You have your local machine, you run node index.js, and it works on localhost port 8080 and you're happy, and you commit, you push, maybe you run your local unit tests, whatever you run it in, and then at some point somebody builds a container with it, has some kind of Helm chart or other orchestration package, and then tries to run it somewhere just to have behavior on the target system, to have behavior during the software running, which you couldn't catch, which there is no way that you could have catched it. And probably if this person is separate from your team and builds this separately somewhere, with you not knowing or using or owning certain things about this process, you will suffer on the long term with having to fix these kind of things. And these are the really kind of hard things. The OOM kill, by the way, it's just because the resource didn't fit what you need. There are much more interesting examples. So instead of having kind of like two complete separate parallel worlds, which are quite different from each other, you should say, no, how I build my container, how I orchestrate my application is part of my project. This is part of my project. I own this. I own this. I want to run this. I want to know how if this works. That doesn't mean that I'm not allowed to do a node index.js and use localhost, but I should be aware of it, and I should know that this is the thing, this is the product I deliver. And what I expose here to somebody else who has then to actually fit it to a specific target system is something I control, or at least document, depending on the tool I use to tell them, hey, look, this is my naive approach of how it should be orchestrated on all systems, and this is kind of the range I want to give you in customization or with custom values, whatever you use to make it fit your system. And there are all kind of scenarios why you should do this. Oops.
I don't have an answer for that. Is there something else I can help with?
So,
I'm sorry, I can't call emergency services here. Please use your phone.
I can't actually steer my iPad. Please, Siri, stop. Okay. Oh, it's gone. It's gone. Sorry. That's funny. I like iPad to draw, but somehow I pushed the wrong button. Okay, let's get back. So one example I want to create, show you. Let's check the time. I think we're quite okay with the time. I want to show you an example of orchestration where it's interesting to know something. So if you have a service in Kubernetes, I just take the example of Kubernetes now. Could be some different kind of load balancer system or whatever you use. You have a service, and here you have your request, and here you have your instances of your application, the same application, backend X, backend Y, backend Z. What happens is that requests are sent to your instances of your software as soon as the orchestration solution, in this case Kubernetes, knows that they are ready. So, but how does the orchestration know that your service is ready? You're right, it doesn't. It doesn't. What it knows is if there is a process ID. And as soon as there is a process ID, it will say, hey, the container is running, I can send requests to it. But that's maybe not what you as a software engineer want to have. So for this, we have a solution. We have something called probes, like a startup probe, which has actions, or which has an action, and it has kind of a timing. You can iterate timing. Now, what I want to talk about is, this is something you as an engineer should think about. Because if it is the wrong action, the orchestration doesn't really know if your application is ready to get requests or not. If it's the wrong timing, it maybe sends requests to the instance of your application too early, too fast, and then they fail. That's kind of like the default behavior. Of course, if you write a REST API in Rust, it's probably available after, I don't know, 5 milliseconds. I don't know how fast they are. But in many other like technologies and frameworks, you have maybe between 10 seconds or whatever, maybe like even 2 or 3 minutes until a service is there. Or if it's a database, it could be even more. So the timing is interesting, and it can change. This can change with your software. Maybe the action doesn't change much, but maybe the timing changes because you realize that your software suddenly takes a bit longer. So you want to give it a bit more time at the beginning before it started to be tested. There are different kinds of things to think about. It's not hard. It's not really complicated. I know many DevOps engineers say, oh, our software engineers, they don't care. They won't understand. They don't have the time. I argue against that. I'm pretty sure if you show the exact examples where they see, the issues I get about failed requests on the production, maybe instead of spending a lot of time in trying to find out why they fail, I know, they fail because my service is getting requests too early. So this is, for example, something that happens. Or another thing I want to add to this is that also can feed into that is if you if you have things waiting for each other, let's say the backend service has to wait on something other XYZ, maybe a database, maybe a Kafka, whatever. What you often see is often see like crash loop backoffs. And the reason for that is that your application throws an error if this is not running yet. So if this is not running, this crashes. And orchestration solutions are very good in restarting this, but then maybe they crash and they loop. So I don't want to go into more detail. There are solutions to solve that, like init containers to wait. But it's things that you as an engineer should think about, because maybe your service or your software project at the moment does not depend on XYZ. And the next release, it depends on XYZ. So it changes the orchestration, and the orchestration is code. So it should be tested, it should be treated as code, it should be versioned. So for me, it's actually the same as your software project. And now you say, yeah, but like in an organization, we have different players helping and doing stuff, and which makes absolutely sense because not everybody has the same priority. But that's the same with your software. If you use whatever PDF generation library or whatever library framework you're using, you're not writing your framework. If you have an internal Angular UI component framework that some team in your organization builds, you're not writing this Angular UI component framework yourself. You're depending on them, and you have to talk to them and you integrate what you want to integrate, and you think about it. And this is what I want to tell you about this whole CI/CD orchestration world. What I often see is us I mean, I'm actually more like here, but I'm also sometimes here. But if I talk about us, I'm actually also this, because at the end I also write code. But let's say we're here writing our software, the software that solves things our users want, and we live in this kind of like my machine, my rules world, and then we hand it over to this kind of like feature branch or whatever pattern you use world, where we often, way too often, have concessions we have to make, or maybe we don't have to make, but because the right people are not talking to each other. When I go to customers and I look at stuff, usually one team says, yeah, we don't have enough servers, and some other people say, yeah, we don't see more servers there. But if you actually explain the things and you kind of like try to understand why it really hurts, suddenly there are more servers, there are more clusters, and suddenly you get more resources. So long story short, we have this my rules world on my machine. We have this kind of like most efficient feature branch lifecycle world. This is the most important one, because that's the shortest cycle here. These two, the my machine and the feature branch. And we push way too much stuff into this main branch or afterthought continuous integration world, which for me is not really continuous integration anymore, because we already integrated. It's more like a last wall of defense. And then we have the production deployment, which often is kind of like its separate world. And we have different people feeding into this world, which makes sense, because each of them has their own way of thinking and their own knowledge and their own position in the whole system. But this doesn't conflict with each other. What I would like to propose or see more often is something like this. I pulled you or me or us down here. I say, okay, we have our machine, we have our rules, we have our code, but we want to base everything on this main core build, test, deploy, and orchestration part of our software project. And because we don't want to build everything from scratch, which we already know how to do in software engineering, like in software engineering, we have dependencies, we have to choose tools, we have to choose libraries. We think about those other players, other peoples with their strengths, which are really important, more as kind of like dependencies or parts we want to integrate into the system. But we want to have a certain ownership about this. First, to iterate fast. That's really important, to iterate fast, but to also get the confidence. Because continuous integration, which gives us the confidence to quickly continue and base our work on changes of others, also means that we are confident that they run on production. We shouldn't just be confident that our compiler doesn't fail. We should be confident that actually what we're building on would also run on production. So this is basically my case. And so the conclusion, and I hope I brought this a bit closer, is own your CI/CD pipelines, own your orchestration. Talk to the people who know how it's done. Talk to the people who do it. Try to maybe turn around the pyramid from having very little access and very little influence on this whole pipeline and orchestration thing. Change it to the other side, where you are basically owning it and you're depending on things others build who are really good at something. Somebody's really good at Argo CD, they should build that stuff for you, but you own it, you depend on it, you integrate it in your project, so you really understand it, and you get these benefits of CI/CD, which we actually want to have from it. Yes, that's it from me. Thank you very much from the presentation. Of course, I'm around for questions, and check out Let's Boot CH, and let's see what questions we have.
Awesome. Great job. Great job on this performance. I really enjoyed this session. I especially like two things. One is that you mentioned that it's all about the confidence, right? And I'm also in the same opinion that, having a proper build pipeline, we can build confidence and we can deliver software earlier and more often. so we can make our customers happier. So yeah, this is a great point you brought up. And also I really like the fact that you emphasize that we should own the pipeline. So we shouldn't have, like separate people. Some people call them DevOps people who are responsible for this, but we as a developer, as a team, so all of us should be DevOps engineers and should be responsible for these pipelines. So yeah, excellent. Really liked it. So we have a few questions, or maybe Valentina.
Okay. Yeah, feel free to share if you wish.
Yeah. Okay, so let's go for the first question. So then the question is, what is your approach for teams who are working in legacy projects with manual deployment and who want to adopt CI/CD pipelines?
So I would work from the CI part. I mean, sometimes the requirement or the request comes from a different side. Sometimes it comes from the CD side. But let's think about the software team now. So I would start with the CI side. I would think about like what's the next most important step that increases velocity for the engineers working on the legacy project. So don't try to get everything completely running with, I don't know, starting a SAP system for every development environment, but work from the parts that benefit them the most. And then also question reality. Often they have constraints which they believe in because the last 10 years they hear it has to be like this. But if you really ask the person that manages that, they suddenly say, no, that's no problem. For example, there is this idea that like Oracle databases are very heavy and it's really hard and expensive to run them, which is maybe true. I don't want to have an opinion on that. But if you talk to the right people and you really tell them what you need is you need to have quickly credentials to access data that you know how they are, like test data, which are always the same. So you need an endpoint with credentials to quickly get an Oracle database with certain data. Now, if you talk to the right people in your organization, suddenly they say, "Oh, that's not really an issue. We can do that for you." So start with what helps them the most, like in making their development cycle faster, and also question like reality, because often they think things are not possible, which are actually possible. Yes.
That's good. I like how you emphasized, looking at what will bring them value soonest. And maybe if you think back to your experiences working, as a software developer and later working with multiple teams in training, what is some typical like transformation pathway? Of course, it's different for every team and each project, but was there any like typical transformation pathway that you took?
So the good ones or the bad ones? So what I often see is that projects start with CD. They build CI for CD, and for me, CI is not for CD. CI is for the software engineers, the software team, and if the software teams can deliver working software, CD is already solved, because the CI. If we go back like 20 years, or maybe even 10, depending on the stack, everything is so much easier. Like, if you want to know your software works, you have to run it. And the tricky part today is that the way we run complex systems on production are so much different sometimes from how we run it locally, that kind of like we have this gap of how to, and it's tricky to fill this gap. So for me, often what I see is they start with CD and then they try to fill in the gaps for CD, which is something you have to do at some point. But I would rather start with things that help the engineers to quickly iterate. And a good thing is to look at what are the painful things they find to fix later on? Like, what are the things you waste a lot of time pre-release? Like not the things you fix daily, the things like you work on multiple branches, whatever iteration time frame you have, or cycle you have, and after a few weeks, after a few months, you want to do a release. What are those painful points pre-release, and how could you have solved that you would have seen this error right when you created the error, and not like pre-release when everybody's already too late and yeah.
That's a good point, looking at those pre-release pain points. And what do you see as some of the biggest, let's say, pre-release pain points that you've seen up to now with teams?
So, I mean, I did some Cypress end-to-end testing stuff. I mean, if you have this kind of like end-to-end testing, critical path focused end-to-end testing in the front end, and you run it kind of an afterthought built by somebody else, that can be quite painful if this is run quite late, because then you suddenly have the situation that what do you do now? Do you fix the test, because software sometimes changes, and then tests have to change because the tests test an old reality, and then also sometimes what I see is that kind of like especially with scaling system, rolling updating system, that basically what's written here doesn't match the way it should be deployed here. So like database migrations, services which depend on database structures or other services which change alongside. If you have multiple repositories, how you keep the versions aligned, who tested with which version of which other service, everything is solvable. I don't say it's this. All of you solved one or two of those cases, but this is kind of, yeah.
Great. Thanks for that overview.
Performance is often neglected. Like resource behavior and performance is often neglected.
Awesome. Great answer. Thanks a lot for this. This is pretty detailed. Let's jump to the next one. We still have a few questions, so very exciting ones. So the next one from Noe. It is crafting software and crafting a build pipeline are two really different things, which require really different skills. I don't have the skills for the latter, and most developers don't. And there is another one, continuation for this. I agree that I must use and understand the CI pipeline, but someone with the relevant skills must create it for me. What is your take on this?
I wrote Angular frontends, and I don't have the skill to build the templating parser for the Angular framework. I wrote end-to-end Cypress tests, and I don't have the time and skill to build the system that does the recheck queue of Cypress. I think it's for me CI/CD, because it's code, and as soon as you start to treat it as code that is run at some point, you can actually use the same patterns you use with other software. So the person who knows to do it the right way should do it, but it shouldn't be like you're not going there and writing your Angular project and then giving it to somebody else to then attach or build the UI components for it. I mean, that's not what you do. What you do is you depend on something, and this is what I mean is like if you have a very homogeneous ecosystem. You can actually, I know customers, they write a lot of they write a lot of Spring Boot microservices. The owning of your CI/CD can be quite small. It could be probably a Jenkins file, with depending on how you do it, and then maybe some orchestration folders with some things you depend on. You have to talk to the people who know how it's done, and then try to find the API on how you integrate it as a part of your software project. I'm not saying you have to build it. I say you should own it. Probably you don't know how the OpenSSL library works, which does the encryption in your software. You look at the API and you depend on it. So, yeah.
Yeah, I totally agree with this take, and it's just yet another skill, I think, and everyone can learn it. It's not it's not a rocket science at all. We just have to embrace it, and also we have to see the positive side of it, that if we really learn this skill, that we can really shorten our feedback loops, so we can save a lot of time. Time is money, so this is a really great and beneficial skill to learn. And of course, the best is to find someone who has experience with it, and let's have a pair programming session with the given person, and you can build your pipelines. And once you build, that's also my experience. I remember back then, 10 years ago, I didn't know how to build pipeline, and I thought, oh my God, it's complex stuff. And once I built my first pipeline, after that, every other, doesn't matter which platform, they are all the same most of the time. I mean, the concept wise, you need to build, you need to package it, you need to push it somewhere, some registry. After that, you need to get it, running the test. So all of them, really based on the same concept. So it's not a rocket science. So I recommend everyone who doesn't have these skills just to get started, build your first pipeline, and from then on, everything will get easier, in my opinion. Okay, I would say let's jump to the next question. Here it is. It says from Valentina, in multi-repository setup, what kind of tests do you have for each repository pipeline? For example, unit tests. Furthermore, what are your perspectives regarding end-to-end tests, and where, when to run them? So here we have two questions. Maybe we can split up if you can.
I was like reiterating my talk this morning in driving with my car back to the office. We're on vacation with my family. I drove to the office 1 hour to give this talk, and then so I was actually thinking about this question. I'm a person who talks to myself a lot, and this is actually a question because it's a hard question. So if you separate microservices, and I'm not the expert in this, there are people who are so much more better at that. But like let's think about it this way. You have multiple repositories with multiple microservices depending on each other. Now there are two worlds. Let's say the one world would be, let's take an example we could imagine. Let's say your one service is called OpenAI. And it's from the company OpenAI. The people at this group, they say, this is our standardized API. This is the test through our API. The API is versioned, and we agree on this API working like this. That's what they expose from their repository. They will not have to test the Angular front end of your chatbot because they don't care. They're a separate company, separate team, and they can say, this is the API. We promise that this API will work this way, so we don't have to test it. The problem is that most real-world projects in companies with multiple services are not like this. It's usually not the case. Sometimes it is, and we should actually, it's more, for me, it's more like a decision and transparency problem than really a technical problem. We have to kind of agree, like, typical case. We have a project with a single page application front end. We maybe have a back end mostly built for the front end. Maybe we have a few more services. Reality is we all run them together. Their main purpose is running them together. Maybe even some people work on several of those services. And we ship them together. If we decide differently, we decide differently, but then the workflow of the project changes. If we decide to treat it as one project, we should also test it this way. So what you can do in a multi-project scenario is you can actually say that if you work on your microservice as part of your continuous integration, you want to have the confidence that the currently stable, not deployed, not released, but the currently a stable considered version of the other services have to work with your service. So depending on your CI/CD solution, you could say, as part of my CI continuous integration of my microservice, I want to run the whole thing together with this version of the microservice. And this is something that is not that easy to do if you're not understanding like how the orchestration works. So what you want to do is you want to say, okay, I want to test my microservice in context of the whole project, because that's the truth. We are looking at it as a part of the whole thing. So in addition to running my unit tests, to running my API tests, to running my performance tests and everything only on my service, I also want to run it in the whole thing, which is probably living in another project. So with a multi-project thing, you probably have this kind of like umbrella project, and this umbrella project basically pulls in on all the other projects. But with an ICI pipeline, you can actually say, hey, I have this kind of feature branch version of my microservice. I would like to run this feature branch version of my microservice in the context of everything and run the end-to-end tests on them. That's kind of like the gold standard, I think. I don't think that's true for everybody, but I think this is the best case. And usually people think that's not possible because they don't talk with the people. The people who know how it's done don't know that you need it, and you who need it don't know that it's actually much easier than you think it is.
That's an interesting perspective. So yeah, I think it's good how you mentioned both the need, on one hand, testing the microservices in isolation, but of course, testing does it all work together, because most commercial projects, it's all about, testing, does it work together. Thanks for that.
Just one more thing to that. You can do it in a way where you say, okay, the backend is really an API, let's say a REST API. We have it versioned, we have it tested, and we have this kind of contract, the specification, how the API should behave. The front end is the consumer. The front end runs the end-to-end tests. And when the front end needs something from the back end, they're like a customer. They go to the back end and tell them through an issue, hey, we'd like to have this API changed. And if they don't have enough time, the front end has to kind of like, we all know how to do it. The front end has to kind of like bridge this time, because then it's like the OpenAI API. Then you say, okay, we built our whatever AI solution, and the OpenAI API doesn't serve what we need now. So the customer maybe still need the feature. So we have to solve it somehow. And we hope that the OpenAI API maybe solves it in 1 or 2 months. And then we can go back and fix whatever we have done. Like a typical case in front end is you have to do too many API calls to REST APIs, because the API in the backend doesn't serve the data you wanted. You can try to solve it with GraphQL, which solves some things, which then hurt a lot on the other area. So for me, it's a decision thing. And if the decision is that you test your API backend in isolation, then you push. Then you have to be transparent about the constraints of how fast you can change something in the backend. If you test it in isolation and then the front end guy goes fixing something in the back end, because you know what I mean? Like, yeah. If you decide on isolation and then basically in reality don't live the isolation, that's the problem. That sometimes politically we think it's isolated, but on the daily work, we don't treat it as isolated.
All right. I think it was a really detailed question and answer. So thanks a lot for that. I would jump to the next one. We still have a few one and really good ones. So the next one from Jake. The question is, how would you recommend starting to learn how to build pipelines?
A pipeline is doing what you need to either deploy something or to test something. If you want to test something, usually you know how to run it locally. So if you want to run your Cypress test, you know how to run your Cypress test. If you want to run your unit test, you know how you run your unit tests. And then the next thing is you need some kind of tooling. You need some kind of GitHub Action, Azure DevOps, GitLab CI, whatever you want. And then you can find a match for what you want to solve. So understand what you actually want to do in the pipeline. That's something I often see that is neglected. Like projects throw big automated black box parts of CI at their projects, which then produce messages or errors that maybe they're not, that's a bit like dark how I describe it. It's not that bad, but like understand what the pipeline should really do, look at the pipeline tool that you need, and look how to do it best with this pipeline tool. Depending on if you use a GitHub action, there could be a GitHub action which really fits what you want to do. And or maybe you have to write your own like this. I mean, building overall pipelines, a good thing is to actually look at other projects, other pipelines that already do something similar, like we do in software projects. I mean, software lives from copying. We live from looking at what others do. No artist is born in a white room and takes paint and starts to paint something. We always look at other stuff. So look at other projects, look at what you really want to do. And the really hard part is like putting everything together and versioning and branching and maintainer responsibilities. And this is the harder part later on. Different kind of releases with and without database migrations and so on. But yeah, look at other projects, look what you really want to automate, and decide on a tool you want to use or have to use. And all of them are great. I hear people that say, oh, Jenkins is so old, you can't do anything with... that's not true. You can do everything with Jenkins. You can do with GitLab CI. I really like GitLab CI. Others like really Jenkins. It's usually less the tool. It's more the patterns. It's just that we know Jenkins is this kind of like nightly manual afterthought build, which is kind of a thing because of resources. Previously, we had less resources and we had this kind of manual thinking, but you can do very nice pipelines with Jenkins, amazingly smart pipelines with Jenkins, and you can do amazingly smart pipelines with GitLab CI. Yeah.
Couldn't agree more. Yeah, basically all of these platforms solve the same problem, so you can do the same with all of them, more or less. Maybe maybe Azure DevOps is more specialized in Azure resources, but you can still do the same with other platforms. And that's a great point you said, that get inspiration from other projects, especially from open source projects, big ones and quality ones. You can find the source code on the internet in GitHub, and even their pipeline is there because it's it's code. So it's stored in their repository, so one can get inspiration from those projects. And I think that that's the easiest. Yeah, all of the platforms, as I said, you can do the same things with all the platforms, but maybe the easiest to get started with nowadays is GitHub Actions. This is really hyped, and Microsoft is behind it. So it's the entry curve and the learning curve is, I would say, the lowest and the easiest nowadays. I mean, that's my experience in the last years, that many projects and many teams are migrating to GitHub Actions because Microsoft is really pushing it. So it's a great platform. But yeah, any other platforms, you can do the same. So yeah, great point. Okay, nice. Thanks a lot for the answer. So let's go for the next one. From Valentino again. What are the typical stages that you have in your pipelines?
That's a tricky question. My favorite pipelines are the ones which are nearly the same for all the branches. So obviously, depending on the stack of technology you have your linting, your static code analysis, your unit tests. If it's a front end, you may have your component tests. I like to separate everything. So if you see in the overview that something fails, that you see what failed, then you want to deploy it somewhere, even in test branches. Feature branches. So you have kind of like a review environment. I have a customer. They have a really fancy pipeline where they They even deploy for every pushed change, they deploy the application several times, because they want to run end-to-end testing with Cypress, and they want to run performance tests in parallel to make the pipeline faster. But you shouldn't start with optimizing your pipeline. Just make it work. Then look at the critical path. So yeah, build, test, deploy, verify, and then depending what you put in verify. So I'm usually dependent on the stage. The customers already have a bit. You maybe have something like prepare environment, tear down. Maybe you have a stage for tear down stuff. Yeah. But the closer your feature branch pipeline is to your main branch pipeline, the happier your life is, or my life is, at least for what I do.
Great. Thanks for that. I like the overview that you gave.
Okay, as a next, there is a vibrant discussion about the topic that there are too many tools, to learn about, all these things. And let me bring one comment about it, and I'm interested in your take. We could talk about this. So here it is from Varam. For creating and managing CI/CD pipelines, you have to know Docker, Kubernetes, Helm, Bash scripting, and so on. So the threshold is high. And also there are some other people mentioning, there are a lot of things to learn, and we can't know everything. So what is your take on this? What are your advices in these regards?
So on one side, there is an issue. So I was at KubeCon. I have the KubeCon T-shirt. I mean, I'm a fan of Kubernetes, but I'm honest. It's hard, and not everything is great about it. So let's say one of the issues is the whole cloud native ecosystem has a huge advantage. We have this Kubernetes core system, which doesn't fill all the gaps we need to fill, but it's super modular, and you can integrate and feed everything into it, which means that for everything you can choose, there are too many options to choose. And like every week, there is a new topic someone wants you to solve. So this is kind of like, it is super overwhelming, like what should be known. But I don't know how familiar most are with single page application, but let's look at the bigger single page application. If you're a team and you write a single page application with Angular, for example, I take this example because it's also quite big. It also can do several things very different. Not everybody in the team has to know how to integrate NGRX state management. It's hard. It's hard to cut your front-end Angular application in different modules, in different to the state management, to also the microservices. I mean, deciding on the right framework, like cutting the services, deciding which tooling to use to specify your APIs, and so on. There are many decisions and things to set up that not everybody in the team does the same time. So if you're working in a team, you should think about where do we get a blueprint, where do we get a good example, where do we get the components we want to integrate. So for example, Helm is a painful thing to learn. It's there, we won't get rid of it for quite a while. There are so many things built with it. But somebody who really knows Helm can build you a Helm chart or has built a Helm chart that really fits already your case, and you basically tailor it to what you need. And you don't have to understand everything to tailor it. So it's kind of, on one side, it's true, it's super hard, it's super crazy, and it's getting more complex, which helps us to sell more trainings. And by the way, it helps us all to be harder to replace with ChatGPT, because the faster we release new libraries and change patterns, the harder it is for large language models to take over our jobs. No, just joking, yeah. So it is hard. Owning and learning it doesn't mean that you write your own operating system in C. It just means you know the concepts, you can work with it, you can understand, does it fit what you need? Talk to the people who know it, search for the tool that fits it. Yeah. And not everybody in the team has to do the same thing. Still, others should know how it's working.
Yeah, that's a very good point. And what I would say here is, I think the best. So you don't need to. One person doesn't need to know everything alone. We as a team should know everything together. And the best thing, the best way to share knowledge and to learn these things together is to do. Based on my experience, we did pair and more programming heavily. It's not like just for 1 hour, but on default, we did this stuff together with the team. We rotated frequently in pair programming, or when we did more programming, then we did it together. And together, it seems easier to do this because maybe you don't know it, but one of your team members surely will know it, or all of you will figure out. So you have a great support because you work together with your team. So that's I would say that's one of the best. In my opinion, that's one of the best way to share knowledge is to do together with pair and more programming, and by doing so, everything will be easier. So I recommend this. And if your company doesn't do these practices, then fix that first, because it's really a industrial and best practice about collaboration. So it's superior to working alone. So yeah, I would say most people should adopt these things.
Yes, CI/CD pipelines are software, so you can solve this. Yeah.
Maybe one thing here that I also have experience with Kubernetes and Helm charts, and it's really one of the most impressive technology in our industry. I'm really impressed how all things are evolved, and also the Helm charts you can do zero downtime deployments and all these things. It's really impressive. I really love the technology. On the other hand, it's quite complex, as you said. Also, it's quite complex. It has a big maintenance overhead, continuous updates. So it's really many times it can be overkill in projects. So what do you see, or what is your recommendation? What can one use if not Kubernetes? So what are the other tools one could use for orchestration instead of Kubernetes? Because Kubernetes, as I said, it's complex. You really need to justify the need of it, because you need it for high scale systems, whatever. But what do you think, what people should use for smaller projects? So what is your experience? What have you seen in other projects?
I mean, the tricky part, like yes, that's actually a really tricky question. So, I mean, going with containers is kind of a thing which makes sense. I gave a talk in New Zealand at Microsoft, and I was talking to the Microsoft engineers after the talk and asked them about, because they gave a talk about .NET with Linux containers, and I was talking to them, hey, do you even do anything with .NET anymore with Windows? And they're like, no. I mean, of course, they have to support some certain versions, but everything they do, even at Microsoft, is really focused on, as far as they told me, on Linux containers. Of course, they will support it for probably 10 more years to whatever. But so containers is kind of a thing. It depends. It depends. If you put something on Kubernetes, you should have a reason. That's important. If you put something on Kubernetes, you should have a reason. And the reason should actually outweigh the cost, because there is a cost of complexity at least. That's the first thing. The second thing is the defaults of the Kubernetes ecosystem are very strongly wired towards highly scalable, no downtime systems. But most systems many systems, especially corporate systems, they can have downtimes. They don't have to do rolling updates all the time. They don't have to scale the cluster. So actually, a lot of things you can actually configure differently. So you can go an easier way. For example, if you say Helm, you do not have to write a Helm chart. If you have a simple target to put your your application to. You don't need to write a Helm chart. In the ecosystem, it's quite difficult. I bring you an example with Docker Swarm. Before I started with Kubernetes, I actually participated in a Docker Swarm course like many years ago. And Docker Swarm is a much easier way to run containers in relationship to each other. It's a bit like Docker Compose. And the people who built Docker Swarm, I met one of those, the company told me that they will actually rebuild it on Kubernetes. So everybody like so it's kind of everything is going towards Kubernetes, not because we need it everywhere, just because if you don't integrate your solution with Kubernetes, it's hard to sell. So this is kind of, I don't say that's good. But if you have the option on going to the cloud, I think container as a service can be interesting. We actually, I was just talking to a customer about container as a service. It's also a trade-off because it usually has some kind of vendor lock-in. Not necessarily. It depends how much you expose yourself towards it. But if you give me a cloud and you give something, some simple service, and maybe you're really dependent on the cloud services and you don't really use the flexibility of Kubernetes, then probably as I don't know, Azure Container, is it called Container Instance or Cloud Run or something like this could be an option. Yeah, that's. I mean, you can do Ansible with Docker on a VM. There are different ways. I mean, if you go WebAssembly, it's a hard question. I don't have a really good answer.
Yeah, it depends absolutely. I'm just interested. What's your take? But I totally agree with you that one should. I mean, if really the Kubernetes is not justified, which is true in many cases, you should really go for some cloud native instances. I don't know, like AWS Fargate or such things, something which abstracts away this low-level orchestration. So, for example, if you want to scale your, for example, one of these instances, you can just click on the button that, hey, I want to have 2 or 3 or 4 or 5 or 10 instances. And I like those tools. Maybe those come with more, I mean, they are more expensive maybe in some cases, but the cool thing is that they abstract away the orchestration. And you're right totally that there is a vendor lock-in, because once you start using these, it's difficult to move out or migrate, which doesn't happen that frequently, but surely there is a vendor lock-in. And yeah, but and also apart from that, it's really important to question, as you also said, whether you really need these. I mean, this complexity. Sometimes, many times, you can really be perfectly fine with a modular monolith system or a modular system with a simple pipeline and CI/CD, and you no need to overcomplicate it. There is even a practice for that. It's from Martin Fowler. It's called monolith first. It's a pattern he invented. You can check his article. You can find internet. Just write monolith first, Martin Fowler. And it's an excellent article about that. Every time when you start a system, and even if you know it in advance that, hey, it will be complex, we would need scaling maybe in the future or probably in a few months, just start with a monolith first. And because it's really, it shapes your mind, and maybe you will end up using the, monolith, because modular monolith can be also perfectly scaled. So many times you don't need Kubernetes. But yeah, absolutely, it always depends, and there is no black and white answer here. But still, keeping it simple, I would say it's a universal practice in software engineering.
By the way, if you're on premise, you can. If you're on premise and you want to provide this kind of like serverless. I say serverless because there is still a server experience. There is also a project called Knative. It's running on Kubernetes, kind of like the pain point. But if you're on-prem, and you have to be on-prem for whatever reason, there are still enough companies. Yeah.
That's a great one.
So you can run Knative somewhere. Yeah.
Awesome. Thanks. So, Jonas, we reached the end of the session. So, I would like to say a huge thanks to you. It was a pleasure to have you. We learned a lot, and it was a great session. And also, would like to say thank you to Valentina to help to host this session. And of course, huge thanks to the audience. We are doing this for you. So, I hope everyone enjoyed this session. So, thank you, everyone. And I wish you a great day further. We were Tech Excellence. Learn how to deliver quality software faster. And don't forget, we are available on social media. And reach us. And if you have any questions about Tech Excellence, just reach us on LinkedIn or any of these platforms, and we are happy to support. So again, thanks everyone, and see you in 2 weeks.
Thank you very much.
Thanks a lot.
Bye-bye. Have a good one. Bye-bye.
Bye, Valentina. Bye, Daniel.
Bye.